Okay, I want to thank our guest, Helmar Francisco, Business Manager Integrated Plan, Francisco Barriento, Solution Service Sales Manager, for being here with us. And we invite you to continue with the conversations here in Siemens Mineral Week. And now coming back to our country and to our place to study, to talk with Luis Jaraquemada. He's Innovation Manager and Technology, Siemens Large Drives Chile, Peru. He will talk about a technology that many of our guests have mentioned. We are talking about the digital twins, or what's happening with them, and the impact of this type of technology, specifically in the mining industry. Thank you, Luis, for being here. Thank you for the invitation. It's a pleasure to be here sharing and talking about these technologies that are being incorporated in the mining since some time ago. We have been talking about this in other conversations in Siemens Minerals Week about the digital twins, and I think it's a good question to start by the basics. What is a digital twin? Well, a digital twin is a term that is being used a lot in the last period of time, as all these words are very in. We have to know what is behind the digital twins, artificial intelligence, and to understand a little bit what is the concept of digital twin. I think it's interesting to analyze some concepts that are related with simulation and the models. Historically, there has been a technique which is a process simulation, simulation of any physical reality, and this is done through creating a model that usually is a mathematical model. It's a model that represents in some way the reality of the physical world, but in an abstraction that is, in this case, in the digital domain. It's a complex representation. It could start very simple, just to have digitization of documents. If you see in the market, there are initiatives and companies that promote digitization of documents as a concept of digital twin. And effectively, conceptually, is something that is correct. But it has a broad area of applications from digitization up to what is the mathematical advanced models based in phenomena of what the electromechanical processes are, based in artificial intelligence, machine learning, so to in some way replicate which is the behavior of a system in the physical world. We talk a lot about the cyber physics systems that is, well, taken to something more simple, is to have a matrix and have the physical reality, but connected among them. It's like a communication bridge. And the difference between the digital twin and this most modern concept with the simulation and the models that historically have been done is that all the technologies that we have seen in these mineral weeks, artificial intelligence, monitoring in real time of process variables, all what is related with virtualization of environment, 3D virtualization, all this technology, besides the capacity of recording, of managing of massive data, has taken that these models that were used for scientific studies, now we can run them in a cloud or in a process that is working in real time, and that could be a mirror with what we really have in the physical reality, connected through all these communication platforms and sensors. Luis, if we take this of the digital twins to mining industry, what is this? How do we apply the concept to the industry? In mining, there is a broad area of applications of digital twins. So to do a connection or a link with what we were talking in relation to industrial issues, usually in a more simple way, something that we used daily, these platforms and these apps that we use for navigation and the geopositioning, that effectively complies with all the features that I mentioned. It's a model that is running in an application that we do have. We visualize all the traffic model of the streets, and the good thing is that it's connected in real time with millions of sensors that are in the street, and there are sensors that are in our phones and that give information of the localization, and that is what we are using. That each person contributes with that in a collaborative way, and so we can have a benefit of this logic of mathematical models that are not that evident for the user, but that are really applying concepts of patterns, functioning of how similar situations have happened not only in the same city but in other places of the world. So that intelligence connected with this real world can give us more information just than a simple model of a map or a mathematical model of traffic in the streets. And this, if we apply it to mining, how do we take this to mining? We can land it in something very similar, the movement of the trucks. The movement of the trucks has sensors that is beyond the GPS positioning. We have vibration sensors, temperature, consumption sensors. We do have broad possibilities of having connection of these models that we have in the cloud or these mathematical models or in relation to what happens in the physical reality. So to take decisions in real time and to try to take the processes to a more autonomous status, that the process itself have its own mind or brain through artif- artificial intelligence, algorithm, machine learning, because of the technological progress. And to complement, how do we take this beyond mining? Because there are many other processes that will come to the trucks. The trucks take large amounts of material that is related to what we're talking before, the haulage of materials. These materials go through a very sophisticated process, crushing, grinding, transportation of material through the conveyor belts, and each of those components, we do have the possibility to virtualize them through mathematical modeling of different types that we can know how we can be testing some type of scenario to do capacity tests of these different components in a virtual system, because in a physical scenario is difficult. It's a system that is producing, and 1 minute of stoppage is million of dollars. So in mining, we are working in a broad area of applications of virtualizing and doing these abstract models. So then do studies and simulations, predictions of how we can optimize all the process. And in relation to that, what problems or what pains maybe are this technology solves, or the concept of the digital twins in the mining industry specifically? The mining industry currently, there are many pillars that support these technological developments, and many of them are related with the sustainability, with the use of the resources. How can we increase efficiency? How can we increase production, safety of the processes and the persons also? And this opens different ways to analyze, and through the models of digital twins, we can do simulations, concept proof. How can we optimize processes? How can we spend less energy? How can we increase efficiency of the processes? How can we reduce the waste of all these systems? How can we do that the life cycle of the components can be longer? How can we use to its maximum real capacity, not only based on the design parameters or when the systems were built, because systems evolve on time. So the digital twin, the good thing is that allows that that model that was initially done according to the construction parameters of the system can evolve and adjust through time. So decisions that were made how to operate a transportation system of material, for example, grinding, according to the initial conditions, are very different to what happens 10 years after, when the system is already working and it has changed. Many changes of the spare parts, changes in relation to the physical reality, the type of material that they are processing. So there is potential in digital twins to do an optimization of these processes in any time of the life cycle of these mining processes. Luis, and to go to specific cases of what's happening in this cluster, Chile, Peru, what concrete examples can you tell us What are you doing? What are you implementing? Well, Sebastian, something very specific happens here in this industry, different to other technological industries that are very advanced in terms of all these technological concepts, artificial intelligence, digital twins. Much of that technology comes from other regions. In the case of Chile and Peru, for us, in our case, in the case of the industry, the mining industry, it's a cluster where there are developments, let's say leading developments. We are developing the first digital twins of certain technologies. We are developing the first maintenance predictive softwares. We are, yes, at the leading edge. Chile and Peru are at the leading edge, specifically if we center in the aspect of the mining industry. Technology companies as us, the companies itself, which are the ones that operate these mining processes, are doing innovations, development and research, and many concepts are being implemented about digital twins that give benefits for what we mentioned, the increase of the production, efficiency, safety. How can we make that the processes are more friendly with the environment? All that is happening, and is happening in advance in relation to other regions. Solutions that are being developed in Chile and Peru are are going out from Chile to the world. That is very interesting because of the potential this development has, and because we are at the leading edge in a very requiring, demanding industry. Luis, let's think in the future. Let's take this technology and this concept of digital twins for the long term. Where are you aiming at? In general, at the level of mining industry and in the technology industry, where are we aiming to this of the digital twins? Is where the artificial intelligence is going, where the monitor in real time is going to processor system, where the capacity of recording, capacity of data storage, and the horizon of all this is how we do that all these processes and this great digital twin of a whole mine, not only at the technical level, but at the level of business variables, at the level of components, digital twins divided in layers, how that can generate a more autonomous operation. What we are working on is how we take all these processes, they can work in a more efficient way to maximize the variables and all these problems that we were talking about. The pains of the mining industry and the most in a most autonomous, automatic way, and that this digital twin can acquire its own awareness and that it allows us to operate in the best standards and to comply so the persons can work in a safer area, safer environment, that we can do operations that are more friendly to the environment, how we can maximize the use of what are the components of the system, how we can increase production, how we make this process more efficient. And I think now we are seeing the tip of the iceberg, as we mentioned, of all these geolocalization platforms. You're using the GPA's data and you're taking it to a mathematical model or artificial intelligence model. But the same phone has many other sensors, vibration sensor, temperature, and the same happens in these issues of the mining industry. We are starting with certain sensors, certain data that are taken from historical data of the mines, but we are going to a level of sensors that is more advanced. We will take advantage of the digital twins. We will learn from the experience, not only from the physical world, but to create cases. And in this virtual system, I will train systems that are of artificial intelligence that need to learn from the experience, but many of these cases in the physical system is difficult to obtain because the failures are not that frequent, because scenarios that we want to identify or predict do not happen frequently in the operations. So the digital twin, what we'll start to do is that it works, and we can replicate and we can create, invent scenarios and prototypes. So to feed systems of artificial intelligence, and then that learning from the digital twin can be used for the physical system and can predict failures, anomalies, and prediction of events, and everything aiming to a predictive maintenance and the autonomous operation of a mining process. And this is fascinating because it has an important power, a lot of potential. There are investments that are being managed so to every day to incorporate digital twins that are more sophisticated. We are facing some projects that are very challenging locally in Chile and Peru, and that we are in the same way replicating that in other places of the world. So on that side, we're very happy to participate in this ecosystem from the point of view of a technology supplier with our experience, historical experience of which are large electrical drives that gives a life to the movement and the transportation of material, processing of all what happens in a mining process. A very relevant experience that we wanted to share in Siemens Mineral Week. Luis, thank you for being here. Thanks for sharing your experience. Very interesting this Minerals Week. We hope to see you next year. Thank you. Thanks a lot. And with Luis, we want to say goodbye to this Minerals Week 2022. We thank for the Siemens Manager of Innovation, Luis Jaraquemada, and we want to thank all our guests that were with us in these three sessions, and also to the sponsors of this session, the Innovation Center, Catholic University, Women in Mining, National Society of Mining, Network Mining, Rumbo Minero Magazine, and CNN Chile. Thank you for being with us, and we hope to see you in the next session talking about mining, digitization, and sustainability.